If you have seen my other recent videos, you will know that I have been playing around with locks recently. Whilst making this video, I found that I hadn't actually filmed everything, so there are some serious gaps. I can only apologise if this video isn't up to my already rather low standards. I have been a recreational lock picker for decades, but about a year ago I had an idea for a lock design that would be quite hard to pick. There are other videos linked in the description about how the lock works. This video is more of my usual subject area, machining. One significant difference with this lock is the design of the outer shell. It has an annular groove around the core. If it was being made for production, this would be done with a custom annular cutter, but in my home workshop I am making the body in two pieces that twist together. The starting point is the centre section of a long Euro cylinder, as will be used in a thick door. I just cut out the centre section, where there are no drillings. I made a special set of soft jaws for my lathe chuck to hold the cylinder profile without crushing it. This was used to face off the two ends to length. I used a D-bit grinder to make a special double-sided boring grooving tool. And used that to machine something related to a bayonet connection into the lock body. The mating part starts as a block of brass with a hole bored in it, mounted on an expanding 5C conic mandrel. This is machined down to size. Another matching bayonet shape was made using a different custom ground cutter. The outer profile of this front part was then machined on the CNC mill. The two parts now rotate into each other. The parts are locked together with a 1.6mm screw into a tapped hole. I failed to video the machining of the outer cylinder, but here you can see the detent track being machined with a cutter that I made on the D-bit grinder. The cutter could clearly do with being a bit sharper. It's pushing up a terrible burr. I am using an existing lock core and keyway. To ensure that the holes in the body line up with the core, I probe their exact spacings with the touch probe. Then the holes can be drilled at a spacing to match the core measurements. I used a carbide drill purely for the stiffness in an attempt to minimise wander. This is one of the areas where I didn't video the process. This footage, or maybe bitage, is of a previous iteration of the design. In this one I assembled all the parts into a pre-drilled body and then drilled the other parts. In the lock that this video is actually about, I drilled the detent hole first, clamped it all together in the V-block as shown, and drilled everything in one operation. The springs and pin stacks are held in place by a sliding dovetail strip. I machined the dovetail with a little cutter that I bought by accident. It came in an eBay job lot of carbide cutters. To make the dovetailed retaining piece, the same cutter was used to machine a piece of brass superglued to a piece of scrap aluminium. I have shown my attachment for Swiss turning lock pins in a previous video. There is a link to the Swiss turning video and the lock assembly in the description.